Welcome to the Arithmetic Zone, and welcome back to Simple Java. I know it's been a while, but finally we're ready to move on from 2D arrays and array lists, and we're on to our next topic, which is going to be class inheritance. So, once again, I set up a new folder, and I set up 3 Java files, each representing a class. So I have a person class right here, where I gave it the instance variables of name and age. I have 2 constructors, a default constructor, which gives name Steve and age 20. And then I have this specific constructor, which passes those values into these instance variables. And I also have a toString method. I also have a worker class right here with much of the same content as the person class, where it has a name instance variable and age instance variable. And it functions pretty much the same, except there's an additional instance variable called job, and in the default constructor I have it set to engineer, and in toString I just add on the job. So right here in my runner class, where I have my main method, I created objects of both of these classes, and I'm going to print them both out. So if I run pressing F5, we see that it first prints out the person object, so name Steve age 20, and then the second object, which is a worker, name Steve age 20 and job engineer. So it works as intended and everything is perfectly fine, but like I said before, this worker class is nearly identical to the person class. The only difference is that I just added on an additional instance variable. So I have the job instance variable, and I had to basically remake all these constructors and methods and add on job. If I were to increase the scope of this project and I'd add even more instance variables, then it'd become even more complicated to keep track of everything. So when you have 2 classes that are about the same, then what you can do is use the concept of inheritance. So we're going to take this worker class and we're going to write the word extends after worker right here. So extends. And extends basically means, what is this class right here? What is it deriving its instance variables and methods from? Well, it's deriving it from the person class. So we're going to say worker extends person. When we set up this relationship, we now made worker a subclass of person, the superclass. And once you do that, what that means is that any worker object you make is also a person object. And when you have that relationship established, you can reuse the instance variables and methods found in person. So how do we reference these instance variables and methods that we already made in this superclass? Well, we got to use the keyword super. So in our worker class right here, let's remove the instance variables in name and age because we already dealt with them in the person class. So let's remove those, and we're only going to have the instance variable job because that's the only new one that we made. So in our default constructor right here, remember, when you make a worker object now, any worker object is also a person object thanks to this relationship, worker extends person. And because in the person class we established that if you just make a regular person object with no parameters, the name is Steve and the age is 20, what you can do is call the person constructor within this default worker constructor. And to do that, we're going to use super. So super is going to call the parent class, which in this case is person. And when you write super parentheses right here, that is essentially a constructor. I'm essentially calling the constructor, the default constructor in person using super. And then once it sets those instance variables, name and age, it's just going to add the new one, job, engineer, like that. Likewise, in this specific constructor right here, where I set the values to these parameters, I can just use super, and then inside the parentheses, I'm going to write n, comma, a, because that corresponds to the parameters in this constructor right here in person. And then, of course, right here in toString, instead of reusing these instance variables, instead, what I can do, because this is essentially the same thing as the person class, the same string, it just adds on job engineer. What I can do is return super.toString. So this is calling the toString method of the superclass person. So it's gonna call this and it's gonna return the name and the age in that format. And then after that, I can add plus and then add a new line, job, and then the job instance variable. So we made all these edits and we managed to simplify this class a lot compared to how it was before. But of course, we gotta run this code and make sure it all works. So let's run it. And it works identically to how it did before. One thing you should note is that when you use the super keyword, make sure that if you're using it in a constructor like this, so if you're constructing an object using the super keyword, has to be the first line in that method. So right here, I have super NA first and then the job instance variable. I can't put the job instance variable first and then put super. That would be an error. So make sure the super constructor always goes first. Alright, so I added a new method called print. In the person class, all it does is just print A. It's a void method. And I also have it in the worker class, except in the worker class, it prints out B. So let's go back into our runner class and let's have these objects, both the person and the worker classes, and we're going to use the print method on both of them. And as you can see, the person object prints A, the worker object prints B, and that makes sense because I defined it as such. But what if I remove this method right here from worker and then I run the code again? This time they both print A. Well, the person class makes sense why it prints A. It's a person object and I explicitly designed it as such so that it prints out A when I call it this method. But for the worker class, well, the worker class extends person. So when Java sees that I'm using the print method on this worker object, it's going to first check worker to see if that method exists. And when it existed before with the print B, it printed the B. But now it doesn't exist. And when it sees that it doesn't exist, it's going to go to person and then see this method right here. It's going to print A. So keep that in mind when dealing with methods. It's going to prioritize the subclass first, and if it doesn't find the method there, it's going to check the parent class. Alright, so I made another edit, and this is a temporary edit where I went into the default constructor of both person and worker, and I basically deleted all the instance variable setting and replaced it with a simple print statement. In the person class, when you make a person object, it's going to print out person. In the worker class, if you make a worker object, it's going to print out worker. So right here in my code, all I'm doing is just making an object for each class, and let's print out and see what happens. Prints out person, person, worker. It actually prints it out 3 times, so let's investigate this. When I make the person object, P1, it's going to print out person, so this is easy to figure out. But then what's going on right here? Why is it printing person and then worker? Well, when I make the worker object, it's going to go into the constructor, and even if you don't have the super keyword, every time you make an object of a class that extends from another class, it's going to implicitly call the super keyword anyway. So it's actually going to print out person because it's making a person object. So it's going to print out person, and then after that implicit super, it's going to go back to the code here and it's going to print out worker. That may be a little confusing, especially with this example, but it's designed this way so that you use your instance variables for your subclasses that are already in the parent class. Alright, so I went ahead and made a couple more classes. As you can see, I made a royal class and a student class, and I also printed out each of the strings that they return when you print them out. So in the royal class, royal extends person just like worker. So what that means is that a class can actually have multiple subclasses. You're not limited to a specific amount of classes that a parent class can have, but each class can only have a single parent. Just keep that in mind. So the person class has 2 children. Now the royal class works pretty much identically to the worker class. The only real difference is that I replaced the job instance variable with position, and the default here is king. And just like the worker class, I use the super keyword to fill the instance variables that already exist in person. So when I printed it out, I get name Steve, age 20, and then the new line position king instead of job engineer. Then we have the student class, and the student class doesn't actually extend from person. No, it extends from worker. So it extends from worker, which already extends from person. And by the way, the parent class in Java, all parent classes in Java link eventually to the object class, and the object class is where the toString and the dot equals method actually come from, in case you were wondering. Anyway, in the student class, it inherits all the instance variables of worker, which inherits all the instance variables of person, so I don't have to redefine name, age, and job. I just add the new instance variable, an integer grade variable. And right here, my default constructor, I actually chose to fill it up with specific values, unlike the other ones, because I always wanted the position to be, or not the position, I always wanted the job to be student when you put it in default like this. And when you call the toString method, it's going to call the toString method of royal, or no, not royal, I'm sorry. It's going to call the toString method of worker, which calls the toString method of person. So it's going to return this string, the name and the age, and then the job, and then the grade. So you can just keep on making these subclasses, and eventually you're going to have a whole specific hierarchy of classes like I made right here. Finally, I'm going to talk about polymorphism, which can actually be a pretty difficult concept to grasp your head on initially. Essentially, polymorphism is the concept that a class can morph into another class if it's related. So when we make this class hierarchy, like we just did, what can happen is that you take an object of a specific class and it can basically take on the properties of another class. So what does that mean? Well, right here, I made an array list of person objects. And as a reminder, every time you're dealing with ArrayLists, make sure you import java.util.ArrayList or java.util.* to just import everything from .util. So I made a person array list, and I'm adding the 4 objects that I made: the person, worker, royal, and student. And you can see that even though this is an array list of person objects, I'm still able to add the worker, royal, and student objects because by polymorphism, they're morphing into the person class when I put it into this array list. So I'm able to put it in there, and then I can just print out all of them at once, just like that. And I did remove the new lines underneath each of the instance variables. I just removed the /n, replaced them with spaces so that it's easier to see. So this is the initial person object. This is the worker object. Right here is the starting from here, that's the royal object, and this is the student object. So a little bit of an eyesore to read, but the point is that you can place objects of different types into this array list so long as they're related to the parent class through polymorphism. Here's where polymorphism can get a little complicated. What it means to morph into objects also means that when I declare objects of a certain class, the classes on each side may not necessarily match. So right here, this P2 object, I'm declaring a person object. I'm allocating space for a person object, but in there I'm creating a new worker object. And this is allowed because a worker is a person. I established that with the inheritance. But here, I can't say that a new person is a worker because, well, not every person is a worker, but every worker is a person. That's the relationship I established. So this is no good. This is just going to cause an error. So we don't want that. But let's investigate this object right here a little more. It's a worker, but it's also a person. Well, let's test that out. So looking into the person class, I reintroduced this void print statement, which prints out A when you call it. And in the worker class, I also have the print method again, but this time it prints B. And I also have this exclusive method to the worker class, just called work, and it prints out working whenever you call it. So with that in mind, let's call the print method on P2. As we saw before, in the person class, the print method would print out A, but in the worker class, it prints out B. But what happens if we have an object like this, where we pass a worker object into memory space for a person object? So let's run the code, and it prints out B. Now, why does it print out B? Well, let's look into this a little more. When you run code in Java with the main method, there's two phases, a compiling phase and a running phase. The compiling phase is how Java determines if your code can even be ran at all. So Java first compiles your code, and if there's an error, the compiling fails, and then your code never actually runs. If the compiling passes, then it goes to the running phase where it just runs the code segments. So in that compiling phase, it's going to check to see if that print method exists in person, which is what this object is declared as. And print does exist. It's right here. Even though it says print out A, it's actually not going to print this out. It's going to go into the running phase after that compiling phase. And in the running phase, it's going to see that this object is a worker object. That's why it's going to print out B instead. Now, instead of print, let's see what happens if I try to call this specific work method that only exists in worker. So p2.work, and even without running the code, you can see that I get the red squiggly lines, which means that I'm going to get a compiling error. And it says work is undefined for the type person. And that's because, again, this is being declared as a person object. Even though it's a worker object, even though it's initialized as a worker object, it's declared as a person. And because it doesn't see the work method in person, even though it's in worker, it's actually not going to run this. So what this means is that when I set up objects like this using polymorphism, I can get certain methods to work and certain methods to not work. And if it sees the same method in the parent class, it's going to run the method that exists in the child class. So like I said, this is definitely a difficult concept to understand, and it can take a lot of practice to see what exactly happens if you run code that deals with polymorphism and class inheritance. But anyway, that's going to be it for today's video. I hope you guys all enjoy the rest of your day and your week, and I hopefully see you guys next time.